Hello, in this lecture we will find out the length of line segment MN. In the drawing we have square ABCD. We know that one side of this square is equal to 12 units, that is to say AB equals to BC equals to CD equals to DA equals to 12 units. And inside this square we have this circle. The center of this circle is at point M. We have also a semicircle. The center of the semicircle is at point N. And we want to find out the distance between the centers of the circle and the semicircle, or we want to find out the length of line segment MN. Okay, so first of all, we will define the point of tendency of tangent AB with this circle as point P. And we will define the point of tendency of tangent BC with this circle as point Q. We will define the point of tendency of tangent AC with this circle as point R. We will define the point of tendency of tangent AC with this semicircle as point S. And we will define the touching point of the semicircle with side DC as point T. And we also will define line segment PB as A, that is to say line segment PB equals to A units according to our definition. And because of the fact that AB equals to 12 units and PA equals to A, then the length of AP is AB minus PB, that is to say AP equals to AB, that is 12 units, minus PB, that is A. So in conclusion, we found out that AP equals to 12 minus A. And in the next step, I will present to you a new rule. This is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. I will read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this circle and we also have point P, this point P is an external point in relation to this circle. Why? Because point P is not located inside this circle, nor on this circle, but it is located outside this circle. Therefore, point P is defined as an external point in relation to this circle. So if from the external point, point P, we will draw two tangents to this circle. So if the first tangent will be this tangent, and the point of tendency of the first tangent in this circle is, we define it as point A, and we will also draw from point P another tangent to this circle. So this is the second tangent to this circle. We will define the point of tendency of the second tangent with this circle as point B. And according to rule number 1, the lengths of two tangents, that is to say the length of the first tangent is PA, and the length of the second tangent is PB. So according to rule number 1, the lengths of two tangents from a common external point, that is to say from the external point, point P, to a circle are equal. That is to say, the length of those two tangents that are equal to PA and PB, the lengths of those two tangents are equal to each other, that is to say, PA is equal to PB. So whenever you draw two tangents to a circle from a common external point to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA is equal to PB. Okay, so here we actually can implement rule number 1 in our drawing. So if we focus on the external point, point B, from point B we have two tangents to this circle. The first tangent is tangent BP, and the second tangent is tangent BQ. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, BP equals to BQ. But according to our definition, BP equals to A. So we can write here that BP equals to A according to our definition, and from this equation A equals to BP equals to BQ, we will derive that BQ is also equals to A. So here BQ equals to A, and because of the fact that BC equals to 12 and BQ equals to A, then QC will be equal to BC, that is 12 units, minus BQ, that is A. So that is to say, QC will be equal to 12 minus A. We will focus on the external point, point A. From the external point, point A, we have two tangents to this circle. The first tangent is tangent AP, and the second tangent is tangent AR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AP equals to AR. But we have already found out that AB equals to 12 minus A. So from this equation, AR equals to AP equals to 12 minus A, we will derive that AR is also equals to 12 minus A. So we can write down here that AR equals to 12 minus A. We will continue to focus on point A. From the external point A, we have two tangents to this semicircle. The first tangent is tangent AS, and the second tangent is tangent AD. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AS equals to AD according to rule number 1. So AD equals to AS according to rule number 1, but according to what is given us in the question, AD equals to 12 units. So from this equation 12 equals to AD equals to AS, we derive that AS is also equals to 12 units. AS equals to 12 units. So here I can write down that AS is equal to 12 units. And what is the value of RS? It is very easy to see from the drawing that RS is equal to AS minus AR. Again, RS from the drawing, it is very easy to see that RS equals to AS minus AR. That is to say, RS equals to AS, that is 12 units, minus AR. We have already found out that AR equals to 12 minus A. So RS equals to 12 minus A. We will open the brackets here, and we'll get that RS equals to 12 minus 12 is 0, minus and minus is plus. So in conclusion, we found out that RS equals to A units. You can write here that RS equals to A units. In the next step, we'll focus on the external point C. Actually, from the external point C, we have two tangents to this circle. The first tangent from the external point C is tangent CQ, and the second tangent from point C to this circle is tangent CR. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, CQ is equal to CR according to rule number 1. But here we have already found out that CQ is equal to 12 minus A. So we can write here that CQ equals to 12 minus A. So from this equation, CR equals to CQ equals to 12 minus A, we will derive that CR is also equals to 12 minus A. So you can write here that CR is also equal to 12 minus A. And what is the value of SC? It is very easy to see from the drawing that SC is equal to RC minus RS. SC is equal to RC minus RS. So SC, line segment SC, is equal to RC, that is actually 12 minus A, minus RS, that is A minus A. So SC equals to 12 minus A, that is to say it equals to 12 minus 2A. So we found out that SC equals to 12 minus 2A. We can write here that SC equals to 12 minus 2A. So, what is the value of diagonal AC? It is very easy to see from the drawing that the length of diagonal AC equals to AR plus RC. So AC equals to AR plus RC. That is to say AC equals to AR, that is 12 minus A, plus RC, that is also 12 minus A. So actually we found out that AC equals to 12 plus 12, that is 24. Minus A is minus 2A. So in conclusion we found out that AC equals to 24 minus 2A. In the next step, I will present to you a new rule that is actually rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So, what is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at this point, point O, and we also have tangent AB to this circle, this tangent AB, this tangent is tangent to this circle at this point. So we define this point as point M. Point M is the point of tendency, so I write it down. Point of tangency of tangent AB with this circle. We will join points O and M together by a straight line. Line segment OM is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point O and ends at point M, that is the point of this circle itself. Therefore OM is the radius of this circle, that is to say we will define it as R. So here we have the radius OM, that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius MO. So AB is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Again, whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, AB will be perpendicular to MO, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So we actually can implement rule number 2 in our drawing. We will join points M and P together by a straight line. MP is the radius of this circle because of the fact that line segment MP starts from the center of this circle, that is to say it starts from point M, that is the center of the circle, and ends at point P, that is the point of this circle itself. Therefore, MP is the radius of this circle, and here we have the radius MP that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AB will be perpendicular to the radius PM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. And we also know that all the angles inside the square are right angles. So angle ABC, that is 1 out of 4 angles of square ABCD, will be equal to 90 degrees. Angle ABC is a right angle. In the next step, we will join points M and Q together by a straight line. Here MQ is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and ends at point Q, that is a point on this circle itself. Therefore MQ is the radius of this circle, and here we have the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. And therefore, whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent BC will be perpendicular to the radius QM. So BC is perpendicular to QM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So here in quadrilateral PBMQ we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees. So 270 degrees plus the size of this angle that is actually angle PMQ. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtract 270 degrees from this equation, and we will get that angle PMQ, the missing angle, equals to 360 degrees minus 270 degrees. It is 90 degrees. So we found out that angle PMQ is a right angle, it equals to 90 degrees. This angle is a right angle. So actually quadrilateral PBMQ has four right angles, and any quadrilateral that has four right angles must be at least a rectangle. So we can write down that quadrilateral PBMQ that has four right angles is at least a rectangle. This rectangle is not a square. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. I'll write it down. The opposite sides of a rectangle are equal to each other. Alright, rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. So here in a rectangle PBMQ, the opposite sides are equal to each other. This is to say PB equals to MQ. PB equals to MQ according to rule number 3. But PB equals to A according to our definition. PB equals to A. So from this equation, MQ equals to PB equals to A, we will derive that MQ is also equals to A. MQ is also equals to A. So we can write here that MQ equals to A. Likewise, according to rule number 3, we will get that BQ is equal to PM. According to rule number 3. But we have already found out that BQ equals to A. So from this equation A equals to BQ equals to MQ, we will derive that MQ is also equals to A. And likewise, it is actually here BQ equals to PM. Side BQ is equal to side PM according to the rule that the opposite sides of a rectangle are equal to each other. That is to say BQ is equal to PM according to rule number 3. But we have already found out that BQ equals to A, and from this equation A equals to BQ equals to PM, we derive that PM is also equals to A. PM is also equals to A. So we actually found out that the radius of this circle is equal to A units, and quadrilateral PBMQ, it is not a rectangle, but it is a square. Why? Because all of its sides are equal to each other, they are equal to A. Okay? So, what is the value? Here, we have already found out that the value of the diagonal AC is equal to 24 minus 2A. So we'll focus on the right triangle, triangle ABC, and we will implement the Pythagoras theorem on the right triangle, triangle ABC. By PT, the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle ABC is AC, so the square of the hypotenuse is AC square, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to AB square plus BC square. I repeat again, in the right triangle, triangle ABC, by Pythagoras theorem, AC square equals to AB square plus BC square. But we have already found out that AC equals to 24 minus 2A, therefore AC square will be equal to 24 minus 2A square, and it equals to AB square. AB equals to 12, so AB square is 12 square, plus BC square. BC is also equal to 12, so BC square will be also equal to 12 square. So here, according to equation number 1, we found out that 24 minus 2A is equal to 12 square, is equal to 12 square plus 12 square. 12 square plus 12 square is 2 times 12 square. Here we take a root out of this equation, and we'll get that according to equation number 1, 24 minus 2A is equal to the square root of 2, and the square root of 12 square is 12. Why? Because the square cancels the root and we left only with 12. So according to equation number 1, we found out that 24 minus 2A is equal to square root of 2 times 12. Here we will add 2A to this equation, and we will also subtract square root of 2 times 12 from equation number 1, and we will get that according to equation number 1, 2A is equals to 24 minus square root of 2 times 12. So here we will divide equation number 1 by 2. We get that A equals to 24 over 2 is 12, minus 12 over 2 is minus 6, So in conclusion, we found out that according to equation number 1, A equals to 12 minus 6 times square root of 2 units. In the next step, we will define the radius of the semicircle as B. That is to say, the radius of the semicircle equals to B units according to our definition. So, here dn is the radius of the semicircle because of the fact that line segment dn starts from the center of the semicircle, that is to say from point N, and ends at point D, that is a point on this semicircle itself. Therefore, dn is the radius of the semicircle, that is to say it equals to B units according to our definition. Likewise, NT line segment NT it is also the radius of this semicircle. Why? Because it starts from the center of this semicircle, that is to say from point N, and ends at point T, that is the point of this semicircle itself. Therefore, NT is the radius of this semicircle, that is to say it equals to B units. And what is the value of TC? The value of TC, line segment TC, actually it is very easy to see from the drawing that TC equals to DC minus DN minus NT. I'll write it down. Line segment TC equals to DC minus dn minus nt. So in conclusion, TC, line segment TC, this line segment is equal to DC, that is 12 units. It is one side of square ABCD that equals to 12 units. Minus dn, that is B, minus nt, that is also B. So TC equals to 12 minus B, that is to say TC equals to 12 minus 2B. We found out that TC equals to 12 minus 2B. We write down that TC is equals to 12 minus 2B in the next step. We will join points N and S together by a straight line. Here NS is the radius of this semicircle because of the fact that it starts from the center of this semicircle, that is to say it starts from point N and ends at point S, that is a point on this semicircle itself. Therefore NS is the radius of this semicircle, that is to say it equals to B units according to our definition. And here we have the radius NS, it is drawn to the point of tendency, that is to say it is drawn to point S, that is the point of tendency of tangent AC with this semicircle. And whenever you have a radius that is drawn to point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius SC. AC is perpendicular to SN, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. And because of the fact that angle NSC is the right angle, therefore triangle NSC is a right triangle. The green triangle is a right triangle because it has one angle that equals to 90 degrees. So we will implement the Pythagoras theorem in the right triangle, triangle NSC. But first of all, we will find out the length of the hypotenuse NC. What is the length of the hypotenuse NC? The length is equal to NT plus TC. NC is equal to NT plus TC. That is to say, NC is equal to NT, that is B, plus TC, that is 12 minus 2B. So in conclusion, we found out that the hypotenuse NC of the right triangle, triangle NSC, is equal to B plus 12 minus 2B. That is to say, the hypotenuse NC is equal to 12, and B minus 2B is minus B. So in conclusion, we found out that the hypotenuse NC equals to 12 minus B. We can write here that the hypotenuse NC is equal to 12 minus B. Now we will implement the Pythagoras theorem on the right green triangle, triangle NSC. Okay, so here according to the Pythagoras theorem, in the right green triangle, triangle NSC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is NC, so the square of the hypotenuse is NC squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to SN squared plus SC squared. Okay? We have already found out that NC is equal to 12 minus B, so NC squared will be equal to 12 minus B squared, and it equals to SN squared. SN equals to, here we have SN equals to B, so SN squared will be equal to B squared plus SC squared. SC equals to 12 minus 2A. So SC square will be equal to 12 minus 2A squared. In the next step, we'll find out the value of the expression 12 minus 2A. So 12 minus 2A will be equal to 12 minus 2 times A, and we've already found out that A equals to 12 minus 6 times square root of 2. So here you will get that 12 minus 2 times 12 is minus 24. Minus 2 minus 6 is plus 12 times square root of 2. So here we have 12 times square root of 2, and 12 minus 24 is minus 12. So in conclusion, we found out that 12 minus 2a is equal to 12 times square root of 2 minus 12. Okay. So now we can substitute 12 minus 2a in equation number 2 here by 12 times square root of 2 minus 12. So we'll do it now. And we will get that here we have 12 minus b squared. 12 minus b squared is 12 squared plus b squared minus 2 times 12 times b, that equals to b squared. And here we'll substitute 12 minus 2a by 12 times square root of 2 minus 12. So here we have b squared on both sides of the equation. So b squared will get cancelled. What is left from equation number 2? After we cancel b squared, what is left is actually 12 squared minus 2 minus 12 is minus 24, so it is minus 24b. That equals to 12 square root of 2 minus 12 squared. So here, according to equation number 2, 12 squared minus 24b equals, here we will take 12 as a common factor out of these two expressions. So 12 was taken as a common factor. What is left from 12 times square root of 2 after we took 12 as a common factor? What is left? It is actually square root of 2. And what is left from minus 12 after we took 12 as a common factor? What is left? It is actually minus 1. All squared. And according to the algebraic identity that x times y on the power of m is equal to x to the power of m times y to the power of m, we get that here, first of all, we have here 12 squared minus 24b equals to, so here, according to this algebraic identity, we get that this expression equals to 12 squared times square root of 2 minus 1 squared. So here we have 12 squared minus 24b equals to 12 squared here we do the calculation of square root of 2 minus 1 squared. Square root of 2 minus 1 squared is equal to square root of 2 squared, that is 2, plus 1 squared, that is 1, minus 2 times square root of 2 times 1. So we have here 12 squared minus 24b, that equals to, we will open the brackets here. Here we have 2 times 12 squared plus 1 times 12 squared minus 2 times square root of 2 times 12 squared. So here we have 12 squared on both sides of the equation. So 12 squared will get cancelled. What is left after we cancel 12 squared from equation number 2? What is left? It is actually minus 24b is equal to 2 times 12 squared minus 2 times square root of 2 times 12 squared. So according to equation number 2, we will get that minus 24b equals to 12 squared is 144. 144 times 2 is 288. 12 squared is 144, and 144 times minus 2 is minus 288 times square root of 2. Here we divide equation number 2 by 24, and we'll get that according to equation number 2, minus 24b over 24 is minus b, that equals to 288 over 24 is 12, minus 288 over 24 is minus 12, minus 12 times square root of 2. Here we'll multiply equation number 2 by minus 1, and we will get that according to equation number 2, b equals to 12 times square root of 2 minus 12. So we found out the value of b, that is the radius of the semicircle. It equals to 12 times square root of 2 minus 12 units. And we have already found out that a is equal to 12 minus 6 times square root of 2 units. And what is the value of a plus b? You can see, it is very easy to see from the two equations that a plus b, it is actually equals to, we have here minus 12 plus 12 is 0, and we have 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. So in conclusion, we found out that a plus b equals to 6 times square root of 2 units. So in the next step, we will join points M and R together by a straight line. Line segment MR is the radius of this circle because of the fact that line segment MR starts from the center of this circle, that is to say from point M, and ends at point R, that is a point on this circle itself. Therefore, MR is the radius of this semicircle, that is to say it equals to A units. And here we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius RM. So AC is perpendicular to RM. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 2. In the next step, we'll do a construction. From point M, we will draw perpendicular on RM. So this angle equals to 90 degrees, according to our construction, because we did perpendicular from point M on RM. So this angle equals to 90 degrees. And we will extend NS, we will extend the radius NS by a straight line until it intersects with the perpendicular from point M, and we will define the intersection point of the extended NS and the perpendicular from point M as X. Again, the perpendicular from point M, the intersection between the perpendicular from point M and the extended NS is defined as X. So NS is the radius of the semicircle that equals to B units, therefore it is absolutely a straight line. NS is a straight line, and when we extended the straight line NS by a straight line, the result must be also a straight line, that is to say NX will be also a straight line, because when you extend a straight line by a straight line, the result must be a straight line also. So when I extended the straight line NS by a straight line, we got NX that is also must be a straight line. So we can write down that NX, line segment NX is a straight line. And we also have rule number 4. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 4 again. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that NX is a straight line, So if we focus on the upper side of the straight line NX here at point S, then the sum of the angles here must be equal to 180 degrees. So which angles we have on the upper side of the straight line NX at point S? We have here 90 degrees. One angle is equal to 90 degrees, and the other angle, it is actually angle RSX. In total, the sum of those two angles must be equal to 180 degrees according to rule number 4. Here we subtract 90 degrees from this equation, and we will get that angle RSX, the missing angle, is equal to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle RSX is the right angle, it equals to 90 degrees. So this angle is a right angle. So actually in quadrilateral RMSX we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle MXS. In total, the sum of those 4 angles, they must be equal in total to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that the angle MSX, the missing angle MSX, equals to 360 degrees minus 270 degrees is equal to 90 degrees. So we found out that angle MSX equals to 90 degrees. Angle MXS equals to 90 degrees. So actually we found out that in quadrilateral RMSX we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So I write it down. Quadrilateral RMSX must be at least a rectangle if not a square. But we know that according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, RM equals to SX. RM equals to SX according to rule number 3. But we know that RM is equal to A, it is the radius of the circle. From this equation, A equals to RM equals to SX, we will derive that SX is also equals to A. So we can write here that SX equals to A units. Likewise, RS must be equal to MX. According to rule number 3, RS must be equal to MX according to rule number 3. But we have already found out that RS equals to A. And from this equation, A equals to RX equals to MX, we will derive that MX is also equals to A. MX is also equals to A. Here MX equals to A. So actually we found out that quadrilateral RMSX is a square. Why? Because all of its sides are equal to each other, they are equal to A. And because of the fact that angle MXN is a right angle, then the triangle MXN is a right triangle. So we can implement the Pythagoras theorem on the right orange triangle, triangle MXN. The hypotenuse is MN, the only missing variable, and we will find out the value of the hypotenuse MN by implementing the Pythagoras theorem on the orange right triangle, triangle MXN. So according to the Pythagoras theorem, in the right orange triangle, triangle MXN, here PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, we will get that the right orange triangle, triangle MXN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is MN, therefore the square of the hypotenuse is MN square. And it must be equal to the sum of the squares of the perpendiculars, that is to say it equals to mx square plus nx square. I'll repeat again. In the right triangle, triangle MXN, according to the Pythagoras theorem, mn square equals to mx square plus nx square. We have already found out that mx equals to a, so mx square is a square plus nx square. Nx equals to a plus b, so nx square will be equal to a plus b square. And it equals to the square of the hypotenuse, which is actually mn squared. That is the missing line segment. We have already found out that the value of A here A equals to 12 minus 6 times square root of 2, and a square is 12 minus 6 times square root of 2 square. And we have already found out that a plus b equals to 6 times square root of 2, so a plus b will be equal to 6 times square root of 2 square, and it equals to mn square. So here 12 minus 6 times square root of 2 square will be equal to 12 square plus 6 times square root of 2 square. It is actually 6 squared, that is 36, times square root of 2 square is 2, and 36 times 2 is 72, minus 2 times 12 times 6 times square root of 2 plus 6 times square root of 2 square. We already found out that it is equal to 72, and all equals to mn square. Mn square so here we have 72 plus 72 is 144 12 squared is also 144. 144 plus 144 is 2 times 144. And here we have 6 times 2 is 12, and 12 times 12 is 144. Here you have minus, so it is minus 144 times square root of 2, and all equals to mn squared. Here we take 144 as a common factor out of those two expressions, and we'll get here that for 144 is a common factor. What is left from 2 times 144 after we took from it 144 as a common factor? What is left? It is actually 2. What is left from minus 144 times square root of 2 after we took from it 144 as a common factor? What is left? It is actually minus times square root of 2, and it equals to mn squared. Mn squared. Here we take a root out of this equation, equation number 3, and we will get that mn, the line segment that we are looking for, is equal to the square root of 144 is 12, and we also must enter to the inside the root the 2 minus square root of 2. So the answer to the question is that the length of line segment MN is equal to either 12 times square root of 2 times square root of 2 units, or in terms of numbers, it equals to 9.18 units. That is the answer to the question. In the next step, I will summarize the lecture. Actually, we wanted to find out the length of line segment MN, that is actually the distance between the centers of the semicircle and the circle. We have here square ABCD. We know that one side of square ABCD equals to 12 units. Inside this square we have a semicircle and a circle, and we want to find out the distance between their centers. That is to say, we want to find out the length of line segment MN. So first of all, I defined the point of tendency of tangent AB with this circle as point P. We defined the point of tendency of tangent BC with this circle as point Q, and we defined the point of tendency of tangent AC with this circle as point R. We also defined the point of tendency of tangent AC with this semicircle as point S, and we defined the touching point between the semicircle and side DC as point T. And we also defined line segment PB as A. Therefore, the value of line segment AB will be equal to AB minus PB. AB is 12, PB is A. So in conclusion, we found out that AP equals to 12 minus A. Then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So if we have the external point, point P, and from the external point, point P, we will draw two tangents to this circle. The first tangent is tangent PA, the second tangent is tangent PB. Then the lengths of those two tangents will be equal to each other. So whenever you draw two tangents to a circle from a common external point to this circle, then the length of those two tangents will be equal to each other. In this case, PA will be equal to PB. So we can implement rule number 1 in our drawing. Here we have the external point B, and from the external point B, we have two tangents to this circle. We have tangent PB, we have tangent BP, and we have tangent BQ. And according to rule number 1, BP equals to BQ, but according to our definition, BP equals to A. So from this equation, A equals to BP equals to BQ, we will derive that BQ is also equals to A. So here BQ equals to A, and because of the fact that BC equals to 12 and BQ equals to A, then QC will be equal to BC minus BQ, that is to say it will be also equal to 12 minus A. Then we focus on point A, the external point A. From the external point A, we have two tangents to this circle. We have tangent AP and we also have tangent AR. And according to rule number 1, the lengths of those two tangents are equal to each other, that is to say AP equals to AR, but we have already found out that AP equals to 12 minus A. From this equation, 12 minus A equals to AP equals to AR, we will conclude that AR is also equals to 12 minus A. We continue to focus on point A. From the external point A, we have two tangents to the semicircle. The first tangent is tangent AD, the second tangent is tangent AS, and according to rule number 1, they are equal to each other. That is to say, AD equals to AS according to rule number 1. But according to what is given as the question, AD equals to 12 units. Here, AD equals to 12 units. So from this equation, 12 equals to AD equals to AS, we derive that AS is also equals to 12 units. Here, AS is equal to 12 units. Okay? So, if AS equals to 12 units, then what is the value of line segment RS? It is very easy to see from the drawing that RS is equal to AS minus AR. AS minus AR equals to RS. Again, RS equals to AS minus AR. We have already found out that AS equals to 12 and AR equals to 12 minus A. So RS equals to 12 minus 12 minus A. We open the brackets and we got that RS equals to 12 minus 12, that is 0. Minus is plus, so in conclusion we got that RS equals to A. Here, the value of line segment RS equals to A. Then, we focus on point C. From the external point C, we have two tangents to this circle. We have tangent CQ and we have also tangent AR. And according to rule number 1, they are equal to each other. That is to say, CQ equals to CR according to rule number 1. But we have already found out that CQ equals to 12 minus A. So from this equation, 12 minus A equals to CQ equals to CR, we will conclude that CR is also equals to 12 minus A. Here we can write down that CR equals to 12 minus A also. Then we found out the value of line segment SC. The value of line segment SC, it is equal to RC minus RS. Again, RC minus RS equals to SC. So SC equals to RC minus RS. We have already found out that RC equals to 12 minus A and RS equals to A. So in conclusion, we found out that SC equals to 12 minus A minus A. So SC equals to 12 minus 2A. So in conclusion, we found out that SC equals to 12 minus 2A. And what is the value of diagonal AC? The value of diagonal AC is equal to AR plus RC. AC equals to AR plus RC. So AC equals to AR, that is 12 minus A, plus RC, that is also 12 minus A. So in conclusion, we found out that AC equals to 12 plus 12, that is 24. Minus A plus minus A is minus 2A. So in conclusion, we found out that AC equals to 24 minus 2A. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. What is the meaning of rule number 2? The meaning of rule number 2 is that if we have this circle and the center of this circle is at point O, we have also tangent AB that is tangent to this circle at point M. Point M is the point of tendency of tangent AB with this circle. OM is the radius of this circle, so we define it as R. We have here the radius OM that is drawn to the point of tendency. That is to say, the radius OM is drawn to the point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius, to that radius. That is to say, in this case, the tangent AB will be perpendicular to the radius MO. So AB perpendicular to MO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So we implemented rule number 2 in our drawing. We join together points M and P by a straight line. MP is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point M, and then at point P, that is the point on this circle itself. Therefore MP is the radius of this circle. And we have the radius of this circle MP that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius, to that radius. In this case, the tangent AB will be perpendicular to the radius PM. AB perpendicular to PM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 2. And we also know that all the angles inside the square are right angles, therefore angle ABC is a right angle, because it is 1 out of 4 angles of square ABCD. We join points M and Q together by a straight line. Here, line segment MQ is also the radius of this circle. Why? Because it starts from the center of this circle, that is to say it starts from point M and then at point Q, that is a point on this circle itself. Therefore MQ is the radius of this circle. And we have here the radius MQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to that radius. In this case, the tangent BC will be perpendicular to the radius QM. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. So in quadrilateral BPMQ, we have 3 right angles, 1, 2, 3, and the 1, 2, 3. And the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle PMQ. In total, they must be equal to 360 degrees. I'll repeat again, 270 degrees plus the size of the fourth angle, this is angle PMQ. In total, they must be equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we got that angle PMQ is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So we found out that this angle PMQ is the right angle, it equals to 90 degrees. So actually we found out that quadrilateral PBMQ has 4 right angles. Therefore quadrilateral PBMQ that has 4 right angles must be at least a rectangle if not a square. So we can write down that quadrilateral PBMQ is at least a rectangle. And then I presented to you rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle PB and Q must be equal to each other. That is to say PB equals to MQ. According to rule number 3, PB equals to MQ. But according to our definition, PB equals to A. So from this equation, A equals to PB equals to MQ, we derive that MQ is also equals to A. Here MQ is also equals to A. Likewise, PM must be equal to BQ according to rule number 3. BQ, here, we have here PM equals to BQ according to rule number 3. But BQ is equal to A. we have already found out that BQ equals to A. From this equation A equals to BQ equals to PM, we will derive that PM is also equals to A. So we found out that PM is also equals to A, therefore quadrilateral PBMQ is not a rectangle but a square because all of its sides are equal to each other. And then we found out the length of diagonal AC. The length of diagonal AC it is AR plus RC. The length of diagonal AC is AR plus RC. We actually found out previously that the length of diagonal AC is equal to 24 minus 2A. So I copied it to here. Is equals to 24 minus 2A. That is what we have already found out. So here we can implement the Pythagoras theorem on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC. So the square of the hypotenuse is AC square. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AB square plus BC square. AC equals to 24 minus 2A, so AC square is equal to 24 minus 2A square, and it equals to AB square. AB is 12, so AB square is 12 square, plus BC square. BC is 12, so BC square is 12 square. So here, 12 square plus 12 square is 2 times 12 square. So in conclusion, according to equation number 1, we found out that 24 minus 2A square equals to 2 times 12 square. We took out of this equation number 1, and we found out that 24 minus 2A equals to the square root of 2, and the square root of 12 square is 12. Why? Because the root cancels the square, and we left only with 12. So in conclusion, according to equation number 1, we found out that 24 minus 2A equals to square root of 2 times 12. So here we added 2A to this equation, and we also subtracted square root of 2 times 12, and we found out that according to equation number 1, 2A equals to 24 minus square root of 2 times 12. We divided equation number 1 by 2, and we got that A equals to 24 over 2 is 12, and minus 12 over 2 is minus 6. So in conclusion, we found out that A, that is the radius of the circle, it is equal to 12 minus 6 times square root of 2 units. Then we defined BC, we defined the radius of the semicircle as B. Therefore, dn, that is the radius of the semicircle, will be equal to B, and nt, that is also the radius of the semicircle, it will be also equal to B. And what is the value of TC? TC, it is very easy to see from the drawing that TC equals to DC minus dn minus nt. Okay, and here TC equals to DC minus dn minus nt. So TC equals to DC, that is 12 units, minus Tn, that is B, minus Tn, that is also B. So in conclusion, we found out that TC equals to 12 minus 2B. Okay. TC equals to 12 minus 2B. And what is the value of the hypotenuse and C of the... But before that, here we join points N and S together by a straight line. NS is the radius of this semicircle because of the fact that it starts from the center of the semicircle and ends at point S, that is a point on this semicircle itself. Therefore, NS is the radius of this semicircle, that is to say it equals to B. So, and we have the radius Sn that is drawn to the point of tangency. Here the radius NS, it is drawn to the point of tangency, that is to say it is drawn to point S, that is the point of tangency of tangent AC with this semicircle. And whenever we have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to that radius. In this case, the tangent AC will be perpendicular to the radius Sn. Again, AC perpendicular to Sn. That is to say, this angle equals to 90 degrees and this angle will also equal to 90 degrees. Therefore, the triangle NSC, the right main triangle, triangle NSC is the right triangle because this angle equals to 90 degrees. So we can implement the Pythagoras theorem on the right main triangle, triangle NSC. And we will find out the value of the hypotenuse NC of the right main triangle, triangle NSC. NC is equal to NT plus TC. NC equals to NT plus TC. So NC equals to NT, this is B, plus TC, that is 12 minus 2B. So here we have NC that is equal to 12, and B minus 2B is minus B. So the conclusion found out that the hypotenuse NC of the right triangle NCS equals to 12 minus B. So now we can implement the Pythagoras theorem on the right main triangle, triangle NCS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, NC square equals to NS square plus SC square. NC equals to 12 minus B, so NC square equals to 12 minus B square. NS equals to B, so NS square is B square. And SC equals to 12 minus 2A, so SC square will be equal to 12 minus 2A square. Then we found out the value of 12 minus 2A. Actually, the expression 12 minus 2A, it is equal to 12 minus 2, and A equals to 12 minus 6 times square root of 2. So we got that 12 minus 2A equals to 12. We open the bracket here, 2 times minus 12 is minus 24, minus 2 times minus 6 is plus 12, so here, in conclusion, we have 12 minus 24 plus 12 times square root of 2, 12 minus 24 is minus 12, and here we have 12 times square root of 2, so in conclusion, found out that 12 minus 2A is equal to 12 times square root of 2 minus 12. So we can substitute 12 minus 2A by 12 minus square root of 2 minus 2A, 2 minus 12 according to this equation. We did it and we got here what is the value of 12 minus B square is, it is equal to 12 square plus B square minus 2 times 12 times B, and it is equal to B square plus 12 times square root of 2 square. So here we have B square on both sides of the equation, so B square will get cancelled. So we have here 12 square, and minus 2 times 12 is minus 24, so here we have minus 24b, that equals to 12. Here we took 12 as a common factor, and inside the brackets we have square root of 2 minus, it is actually minus, it is here, we took a common factor 12 out of this expression, and we got that this expression equals to 12 times square root of 2 minus 1 square. According to the geometric identity, that x times y in the power of m equals to x to the power of m times y to the power of m. So here we got the 12 square minus 24b equals to, according to this algebraic identity, it equals to 12 square times square root of 2 minus 1 square. Here we have 12 square minus 24b equals to 12 square. We open the brackets, we calculated the value of 12 to square root of 2 minus 1 square, square root of 2 minus 1 minus square root of 2 minus 1 square equals to square root of 2 square, that is 2, plus 1 square, that is 1, minus 2 times square root of 2. So here we have, we got the 12 square minus 24b, we open the brackets here, and we got the, here it will be 2 times 12 square, plus 1 times 12 square, minus 2 times square root of 2 times 12 square. Here we have 12 square on both sides of the equation, so 12 square will get cancelled. And we're left only with minus 24b equals to 2 times 12 square minus, here it is minus 2 times of 2 times 12 square, and minus 24b equals to 12 square is 144, 144 times 2 is 288, and we have here 12 square, that is 144, minus 2 is minus 288, times square root of 2, we divided equation number 2 by 24, and we got that minus 24b over 24 is minus b, 288 over 24 is 12, and minus 288 over 24 is minus 12. So in conclusion, we got that b equals to 12. Here we have minus b equals to 12 minus 12 times square root of 2. We multiply the equation number 2 by minus 1, and we got that b equals to 12 times square root of 2 minus 12. We have already found out that a equals to 12 minus 6 times square root of 2. And here we did the calculation of a plus b. Here a plus b will be equal, it's very easy to see that a plus b equals to minus 12 plus 12 is 0. And we have 12 times square root of 2 minus 6 times square root of 2 is 6 times square root of 2. Okay, then we actually join together points M and R by a straight line. MR is the radius of this circle because of the fact that it starts from the center of this circle, and ends at point R, that is the point on the circle itself. Therefore, MR is the radius of this circle, that is to say it equals to A, and we have the radius MR that is drawn to the point of tendency, that is to say it is drawn to point R, that is the point of tendency of tangent AC with this circle, and whenever we have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to the radius. In this case, the tangent AC will be perpendicular to the radius RM. AC is perpendicular to RM, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Then, from point M, we draw perpendicular on RM, so this angle equals to 90 degrees. Then we extended NS, and until it intersects with the perpendicular from point M, and we define the intersection point between the extended NS and the perpendicular from point M as X. So we have here quadrilateral RMXS, and here we know that NS is the radius of the semicircle, it must be a straight line. And after we extended the straight line NS by a straight line, we got a straight line. That is to say, NX will be still a straight line, because when you extend a straight line by a straight line, the result will be still a straight line. So NX is a straight line, and we have, we can write down that NX is a straight line, and we have rule number 4 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so here if we focus on the upper side of the straight line NX at point S, which angle we have here? We have here 90 degrees plus angle RSX. In total, the sum of those two angles must be equal to 180 degrees. 90 degrees plus angle RSX equals to 180 degrees according to rule number 4. We subtracted 90 degrees from this equation, and we got that angle RSX equals to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that this angle is a right angle, therefore quadrilateral MRXS is 1, 2, 3 right angles. So the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of the fourth angle, that is actually angle MXS, in total they must be equal to 360 degrees. Again, 270 degrees plus the size of the fourth angle, that is actually angle MSX, must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 270 degrees from this equation and we got that the angle MSX equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this angle MXS is right angle. So we found out that in quadrilateral RMSX we have 4 right angles. Therefore, quadrilateral RMSX must be at least a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, RM equals to SX. Here, RM equals to SX. But we have already found out that RM is equal to A. It is the radius of the circle. So from this equation, A equals to RM equals to SX, we will derive that SX is also equals to A. So we can write here that SX is also equals to A. Likewise, according to rule number 3, RS must be equal to MX. RS must be equal to MX, but we have already found out that RS equals to A. So from this equation, A equals to RS equals to MX, we derive that MX is also equals to A. Here, MX is also equals to A. So, angle MXN is equal to 90 degrees, therefore the orange triangle MXN is a right triangle. That is to say, we can implement the Pythagoras theorem on the right orange triangle MXN. We've implemented the Pythagoras theorem on the orange right triangle MXN. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is Mn, so the square of the hypotenuse is Mn squared. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to mx squared plus nx squared. So mx is equal to a, so mx squared is a squared, plus nx is a plus b, so nx squared is a plus b squared. So in conclusion, we found out that according to equation number 3, a squared plus a plus b squared equals to mn squared. We have already found out that a equals to 12 minus 6 times square root of 2. Therefore, a squared will be equal to 12 minus 6 times square root of 2 squared plus ab squared. We already found out that ab equals to 6 times square root of 2. Therefore, a plus b squared will be equal to 6 times square root of 2 squared, and it equals to mn squared. We open the brackets here, and we got that 12 minus 6 times square root of 2 equals to 12 squared, plus 6 times square root of 2 squared, that is 72, minus 2 times 12 times 6 times square root of 2. And here we have also plus 6 times square root of 2 squared. We only found out that it equals to 72. And all equals to mn squared. So here we have 12 squared is 144, 72 plus 72 is also 144. So we have here 144 plus 144 is 2 times 144, minus 6 times 2 is 12. Here 6 times 2 is 12, and 12 times 12 is 144. So it is minus 144 times square root of 2, and it equals to mn squared. Okay, then we take out 144 as a common factor out of those two expressions, and what is left from 2 times 144 after we took from it 144 is a common factor. What is left? It is actually 2, and what is left from minus 144 times square root of 2 after we took from it 144 is a common factor. What is left? It is actually minus square root of 2 units. Okay, and here we took out of this equation number 3, and we got that the value of mn, the line segment that we are looking for, equals to either the square root of 144 is 12, and we also must put root to the expression of 2 times root of 2, because we took a root to this expression. So in conclusion, we found out that the value of line segment MN, that is the distance between the center of the semicircle and the circle itself, it is equal to either 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. So I'll repeat again, the value of line segment MN, that is the distance between the center of the semicircle and the circle of the and the center of the circle itself, the distance between the centers of the circle and the semicircle, that is MN, it equals to either 12 times square root of 2, 12 times square root of 2 minus square root of 2 units, or in terms of numbers, it equals to 9.18 units. Okay? Thank you very much.